Okay, hi. We're back with the same problem. We're going to do part C, which is the angle formed. Oh, but I need a marker. Oh, thank you. All right. Part C. I want to find how fast the angle. How fast the angle's changing. Is this angle getting smaller or bigger?
Smaller.
Here to here to here to here. So two things. My angle should be getting smaller, right? So it should be negative. I guess my d theta dt should be like the negative number. And negative number. Thank you. Class is over and there's nobody left. I don't know who that is.
What?
Thank you. Okay. So is that okay? My angle should be getting smaller. D theta dt should be negative. Okay. Here's a problem though. That's h, and that's b, and that's 17. I need a relationship between theta, b, h, and theta, b, 7, theta, h,
Let's
17.
do some trig.
Sine.
Because if you do
Trig.
sine, yeah.
Theta, b, h.
No, let's do theta. The sine of theta equals h over 17.
Did you know there are 12 different ways to do this problem? Wow. But if you were to do like, I'm just gonna play with something here. If you get tan theta equals h over b, then you have to go like secant squared of theta d theta dt, then a quotient rule over here. Yeah, it's not bad. It's not bad. Somebody says, "Oh, I want to do isn't sine inverse of hb?" No, just kidding. Sine inverse of h 17ths theta, right?
Mm-hmm.
Do you really want to take the derivative of sine it? 1 over square root of 1
No.
times equals? No?
Just do sine.
Okay, so it's probably easiest to do something nice and positive, nice and smooth. Isn't it true that sine of theta is equal to opposite over hypotenuse? Just that. Really, really clean. Now let's not lose sight of what we're doing. What we're doing is trying to find d theta dt. And what's the derivative of sine of something? Cosine of something
Times the derivative of sine.
times the derivative of something. There it is. Cosine theta d theta dt. Is that okay? I have to have it solved for somewhere. Equals. Okay, now, I want everybody to just look at this for a second. Because just because it looks like a fraction doesn't mean I have to do quotient rule, right? I actually would not have to do quotient rule. Because if I said to you, hey, what's the derivative of 3x? You're not going to do like product. Even if I say like what's the derivative of x thirds, you're not going to do quotient rule. You just know it's a third. Because x over 3 is a third of x, and the derivative of a third of x is just a third. So the derivative of 17th of h
17th of h
is
prime.
1/17 times the
Times.
derivative of the something,
DHT.
which that's where your DHT comes from. Hey, don't we know DHT?
Yeah.
Yes. It's
Negative 3. Oops, just kidding. Times negative 3. Oh, now we got to think. Because if this is 8 at that moment and this is 15 at that moment, and I've got cosine theta d theta dt, we need to find cosine of theta at that moment. But we know how to find cosine of theta at that moment. Because if we're standing here at theta, what's cosine? Which ratio is cosine?
Adjacent over hypotenuse.
X over y, x over r, I mean, right? Adjacent, x over whatever z, whatever that wants to be. Hey, so cosine is adjacent over hypotenuse, so katoa. So cosine of theta at that moment is 8/17. Ooh! Huh? Don't bother multiplying both sides by 17. Get rid of it, because both sides have a 17. Multiply both sides by 17, they're gone. And then 8 ddt's 8 d theta dt's is negative 3. Divide both sides by 8. Now, this is something we haven't talked about a whole lot. But your angle is actually decreasing at negative 3/8 radians, as all derivatives are done in radians, not degrees. We'll talk more about that later if you want. But if somebody's like, I'm not crazy about 3/8 of a radian. How many degrees is... I would convert between radians to degrees
Don't you?
and multiply it by 180 over pi.
Yeah.
What's that? 45 times. 22 and a half?
Yeah.
67.5 over pi. What's that? Here's where I leave my answer. What is it? Anybody know? 675 over pi. 20 something
Degrees per second.
degrees per second. Somebody wants to show me? Tell me. 675 divided by pi. I'm curious. What's 675 divided by pi?
No.
I get a calculator. What? And we're going to use 3 decimal place accuracy. 21.5. 497. 5497. 49. What?
It's 497, not 5.
No 5. 21.497.
497.
What's the next number?
It's 498. 4968, so I said
497 degrees per. Wow. It's like 20 degrees a second. That's really cool. You can just leave it right there. Negative 383 per second. Now, one quick note before we finish this one. You could have done this 11 different ways. Feel free to try it, but you're still going to get negative 3/8. So, what we did, found out how far it was going out, positive 45/8 feet per second. How big the area? I think it should be getting smaller. It is. Bigger. It is. 483/16 feet squared per second. You're like, should I change that to a decimal? No, just leave it. And then angle's getting smaller, negative 3 to 3 per second. And that's how you do blue sheet number 3 on related rates. Thank you.